Hi, thanks for coming back. This is Algebra Honors Unit 7 on polynomials. This is our Day 5 set of notes, and it's our second video for that. So we're factoring trinomials where the leading coefficient is 1. That's what I mean by a equals 1. And this is the second part of the notes. We just finished remembering how to factor out a greatest common factor. And we were factoring where the greatest common factor might actually be a binomial and not just a monomial. So let's take a look. We're going to factor by grouping. So this will come in handy, particularly in Algebra 2, I believe. But it's a good thing to be learning about right now. You'll just need it again later. All right, so we're going to look at a trinomial. Sometimes actually more than a trinomial, but right now we're going to look at trinomials. And first, you always want to keep in mind that you have to look for a greatest common factor, because your life will be much, much easier if you get that greatest common factor out first. That's your number one. Then we're going to call it creating or completing a factor puzzle. So anyway, I'll show you what that looks like. It's this lovely little X we're going to use. So after we find the answers to our puzzle, we're actually looking for the numbers that are going to go in those two side spots. After we find those numbers, we're going to write a new polynomial where we have broken up our middle term, and then we're going to pull out the greatest common factor. So let's show you how it's done. All right, I'm going to use standard form of a trinomial here, ax squared plus bx plus c. And remember, my a here is my leading coefficient, and it's the coefficient before the x squared term. B is the leading coefficient, not leading coefficient, forgive me. B is the coefficient before the x term, that middle term, and then c is your constant, okay? A is always with x squared, so incidentally, if you did not have an x squared term, a would be 0. So just keep that in mind. B is always the coefficient of x. Okay, so let's just drop down here and let's just actually do one of these problems. So I'm going to factor this trinomial. And so I'm going to remember what a, b, and c are here. A is 1, b is 3, and c is 2, right? Because I've got an invisible 1 there. And we said in this little puzzle, pull down a little bit, at the top of my x here, I have a times c. 1 times 2 is 2, right? At the bottom, I have my b value, so that's 3. So every time I'm doing one of these puzzles, I'm trying to figure out what two numbers multiply to give me that 2, but add together to give me that 3. So sometimes there's some guess and check involved in here. If I think about two numbers that multiply to give me 2, I have one single option, right? I can multiply 1 times 2. So these are the numbers that I'm going to use. I'm going to use 1 and 2. And this will seem more handy when we have more options in a little bit. So just bear with me. Trust me, let's just do this. Okay, I have a 1 and I have a 2. So see how my trinomial right now says x squared plus 3x plus 2? I'm going to rewrite it so that it's x squared plus, I'm going to pull these numbers. So I'm going to say this is 1x plus 2x, and then still plus 2. Okay, so I've just changed 3x into 1x plus 2x. Why would I do that? Well, I'll show you. Now I can actually pull a greatest common factor from this from the first two terms, and I can also pull a greatest common factor from my second two terms. So watch what happens. I can pull an x here, so I'm going to have x times x plus 1. And over here, I'm going to pull out positive 2. Okay, so I am going to say plus 2 times, when I take 2 out of 2x plus 2, I'm left with x plus 1. Right? 2x divided by 2 is x. 2 divided by 2 is 1. The whole reason I did that is, look, I have x plus 1 and I have x plus 1. So I'm going to now pull x plus 1 out. I have x plus 1 as one factor, and I'm left with the x and the 2. So I have x plus 2. So we practiced that on the last video just a little bit. So if you want to go back and see how I did that in the last video, you can do that. All right, so I think these are my two factors. I'm just going to double check. I'm just going to double check because that's a good idea. Okay, x times x is x squared. Outer is 2x, inner is 1x, so I have 3x. And last is 1 times 2, which is 2. So I look back up, and sure enough, when I multiply those two factors together, I end up with a trinomial that I started with. Okay, so I promise this will, you'll think that it is worth all the work when we have more complicated cases. All right, so if you want to think about this a different way, remember, we're always thinking about what two numbers multiply to give me the upper part of my x, and what two numbers add to give me that lower x. So the factors of 2, factors are things that multiply together, and they have to have a sum when you add them together of 3. And so I can think to myself that I could multiply 1 times 2, right? 1 times 2 is 2. And if I added 1 plus 2, I would get 3, right? I just want you to keep in mind, I also could multiply -1 times -2, right? -1 times -2 still is positive 2. But when I add those together, my sum is -3. So we are always looking for the exact precise combination that's going to give us our two parts of that x puzzle. All right, let's see if we can make this look more worth it. So I have x squared minus 10x plus 21. And so I know that a equals 1, b equals -10, and c equals 21. Okay, so the top of my little x puzzle is going to be 1 times 21, which is 21. And the bottom of my little puzzle is going to be that -10. What multiplies to give me 21, but adds together to give me -10? So I know 7 times 3 is 21, right? When I add 7 and 3, I get 10. So I'm close, but I need to rethink. How else can I get 21? I can say -7 times -3, right? -7 times -3 is going to give me positive 21, but when I add -7 and -3 together, I'm going to get -10. So these are the coefficients that I'm going to use when I break apart my middle term. Okay, come over here, let's break apart our middle term. I have x squared. I'm going to say minus 7x because of this, and then minus 3x because of that. So I have x squared minus 7x minus 3x plus 21. I haven't really changed it except that in my first trinomial, except that I broke apart that -10x, right? Let's box that guy off. Okay, so now I'm going to pull a common factor out of two of these terms. So x squared minus 7x, I can pull an x, and I'm left with x minus 7, right? And over here, if I want to have x minus 7, because that's what I'm looking for, right? I'm looking for matching binomials. So I'm going to actually pull -3 out. -3 out. Because -3x divided by -3 is just going to be x. And 21 divided by -3 is going to be -7. Okay? So I pulled a -3 out. You just always want to be looking for matching binomials. That's what we're going to do. Now I can pull that matching binomial out, x minus 7, and I'm left with x minus 3, right? I pull the x minus 7 out, and I'm left with x and -3. And if I double check, it's going to be x squared minus 7x minus 3x plus 21, and that is exactly the trinomial I wanted. Okay, again, with our puzzle, we were looking for factors of 21 that give us a sum of -10, so really don't lose your negatives, right? And so we thought about factors, and of course I could have done 1 times 21, right? But when I add those together, I get 22, so that didn't work. And I could have done 3 times 7, and when I add those together, I get positive 10. So close, but no banana, yeah? Okay, now I'm going to switch to my negatives. And the thing is, you know, if you need a negative middle term, at least one of your factors has to be negative. That's just all there is to it. So I'm going to try -3 times -7, and I get -3 times -7 is positive 21, so that works. And when I add them together, I get -10. So check. The other thing that I could have had -1 times -21, right? And then I would have had -22, also not correct. Okay, so there are multiple ways, of course, to find these binomials, these factors of the trinomials. So I'm going to just show you a different way that doesn't even use the X puzzle, just for kicks, okay? I know if my leading coefficient is 1, I know I have to have 2 binomials. And my first term in each binomial is going to be x, right? Because that's the only way, x times x, to get x squared. So if that's the case, I can do a little guess and check here, right? My last 2 terms, so I'm going to start with my first from FOIL, and I'm also going to think about my last. My last 2 terms multiplied together have to be -12. Well, for me to get a negative number, I have to have one positive number and one negative number, right? So I need to get to 12. Fine. So I'm thinking in my head, kind of guess and checking. If I want -12, this is where your X puzzle actually comes in handy. But you can guess and check too. So -12, I might try like -2 times 6, because that gives me -12. But when I add -2 and 6, I get 4. I'm looking for -1, so I realize, well, that's not quite right. So I'm going to try -4 times 3. -4 times 3 gives me -12. And if I add -4 and 3, I get -1. So that's it. That's the combo that I want. Okay, so I'm going to say x plus 3, because 3 was positive, and x minus 4, because my 4 was negative. All right, so I'm just going to check. X times x would be x squared. This is my check. Outer would be -4x, inner would be 3x, and last would be -12. So when I simplify x squared minus x minus 12, it worked, right? It matches the trinomial that I started with, so I know I've got the right factors. It's important to check, especially with positives and negatives, when you have any negatives at all, because you just want to be sure that you didn't accidentally switch your plus and your minus. Okay, if you had wanted to do this guy using your X puzzle, we would put A times C in the top, so -12, and we would put -1 in the bottom. This is where you would be trying to find your factors, -4 and 3. You multiply -4 times 3 and you get -12. You add -4 and 3 and you get -1. All right. So let's see, over here, x squared plus 5x minus 24. Again, if I want the kind of guess and check thing, guess and check, and guess and check. I know my first terms have to be x, right? Now I'm trying to think of things that multiply to give me 24, negative, right? But add to give me 5. So I'm thinking 6 times 4 is 24, but 6 minus 4 is 2. And 4 minus 6 is -2, so it's not 2 that I want, so I've got to come up with other factors. I know 8 times 3 is 24, right? So if I do +8 times -3 and add them together, oh, look at that. +8 and -3 is going to be 5. That's what I want. So I want +8, because I want to end up with positive in my center, and -3. So a little guess and check again, right? I'm going to check this. If I check, is going to be x squared minus 3x plus 8x, so that's plus 5x, and then minus 24. Check. So really do check. I can't tell you enough. Okay, one more time. If I had used the X puzzle here, A times C is -24. I want to multiply to get to -24, and then my middle term was +5, so I want to add together to get to +5. And I know that my bigger number here, if I'm going to be adding them together and I want it to be positive, the bigger number has to be positive, right? So I'd have 8 and -3 like that. All right. I'm going to go back to the factoring out way and using the X puzzle thing, but you can use either, okay? So here, A times C is going to be 18, and then B is going to be -11. Right? So I need 2 numbers that multiply to give me 18, that add together to give me -11. Okay, if I have to multiply to be 18, they both have to be positive or they both have to be negative, right? I know they have to be negative because I have to add them together and get a negative number. So luckily with 18, my options are 1 and 18, or 3 and 6, or 2 and 9, right? 2 and 9, those are the numbers I need, because 2 times 9 is 18. But I need to end up with negative 11 when I add them together. So I know it's going to have to be negative 2 times negative 9, right? Negative 2 times negative 9 is 18. Negative 2 plus negative 9 is negative 11. So sometimes you have to be writing stuff down on the side of your paper somewhere. Sometimes it doesn't come straight to you, and you just have to try some numbers. Okay, so remember, we're going to take these center pieces of our x, and we're going to break up our middle term that way. So I'm going to rewrite this as x squared minus 2x minus 9x, right? Minus 2x minus 9x, and then still plus 18. All I did here was I broke up negative 11x into negative 2x and negative 9x. I did that so that I can look for greatest common factor, pull out a monomial. That's a really lovely bracket there. Let's pretend I could draw a bracket. X squared minus 2x. I'm going to pull x out. So x squared divided by x leaves me with x. Negative 2x divided by x leaves me with negative 2. And over here, if I pull out negative 9, I'm going to end up with negative 9x divided by negative 9 is just x. And 18 divided by negative 9 is negative 2. Okay? If you're doing something like this and you end up with, say, x minus 2 and x plus 2, just double check. Maybe you need to pull a positive out instead. Okay? So our goal was to have a binomial that we could pull out. We have the same binomial, x minus 2, so we're going to pull that out. Okay, I'm going to say x minus 2 is out, and then I'm left with x minus 9. Okay, check. I'm going to have x squared minus 2x minus 9x plus 18, and that is correct. All right. So x squared plus 3x plus 18. This, again, this is one that I would just do some guess and check, right? Especially because everything is positive. So I know that I know x times x is x squared, and to get to 18, I know it's 1 times 18, or it's, 1 times 18, or 2 times 9, or 3 times 6, right? So 1 times 18 gives me 18, but 1 plus 18 is 19. That's not what I want. I want 3, right? 2 times 9 is 18, but 2 plus 9 is 11, and I look, and that's not right. I want 3. 3 times 6 is 18, but I add 3 and 6 and I get 9. That is not right. But if I change these all to negatives, I'm just going to get negative 19 and negative 11 and negative 9. So I'm looking at this and thinking, there's no way. It's true, there's no way. There's no way. So if there is no way to break up a trinomial into factors at all, we call it prime. Just like any other prime number. I cannot find 2 factors that work there because there was no way for me to find a times c that when I add the factors together I get 3. There was no way. Not possible, right? Okay, remember prime numbers are numbers like 5 that are divisible by only 1 in themselves. That's our trinomial here. Right? Okay. So that one was prime. That one had no solution. All right. Number 7. Remember, and I haven't been saying this every single time because I knew that my x term was, my leading coefficient was always 1. If your leading if your leading coefficient is not 1, look and see if there's a greatest common factor, okay? In our next lesson, we're actually going to talk about what happens if your leading coefficient isn't 1 and there's not a common factor. But today, you're going to assume if your leading coefficient is something other than 1, we got to pull something out. So 2x squared minus 8x minus 24, they're all even for sure. They're all divisible by 2. Let's divide 2 into everything. So 2x squared divided by 2 is just x squared. Negative 8x divided by 2 is negative 4x. Negative 24 divided by 2 is negative 12. Okay, so I already have 2 factors, right? But I also am going to want to factor this trinomial. Don't lose this 2. That 2 is really important, and that 2 will be very sad if in your final answer you forget about it, okay? So don't forget your 2, okay? He's important. All right, I now have x squared minus 4x minus 12. So a is 1 and c is negative 12, right? So 1 times negative 12 is negative 12. And then down here, I need to add my factors together, and they're supposed to add up to equal -4. -12 means that I'm going to have one positive number, right? And one negative number. I know that already because that's the only way I can multiply things together to get a negative. I want when I add them together, I want my sum to be -4. So I want whichever the bigger number is, I'm going to make it be negative. All right, 12, of course, is 1 times 12. So if I said 1 minus 12, that's -11, not -4. 12 is 2 times 6. So if I say +2 and -6, I'm going to say 2 minus 6 is that's it, right? So I'm going to put +2 and -6. Okay, +2 times -6 is -12. 2 minus 6 is -4. So I found my two pieces. Don't lose your 2. Don't lose that outer 2. Don't do it. Okay, 2 times. I'm going to break up my trinomial. Remember, I'm just breaking up the center term. I have x squared. Look over here. Plus 2x minus 6x minus 12. Okay, -4x, I broke it up into +2x minus 6x. Okay, so now I can, look, better brackets. Okay, now I can break up those terms. Okay, so I'm going to say that I still have 2, don't lose it. And I'm going to pull out my x. So I'm actually going to give myself bracket. It doesn't matter, but it'll be easier for you to see what I'm doing. I'm going to pull out an x. So I have x times x plus 2, right? Now over here, I'm going to take out -6. So I'm going to say -6 times, it's going to be -6x divided by -6 is just x. -12 divided by -6 is +2. Okay, so I have found a matching binomial that I get to pull out. Do not lose your 2. 2 still there. And then I'm going to say I have x plus 2. And what did I leave behind? X minus 6. Okay, you don't actually need those brackets. I just had them there so that we could keep the 2 all the way on the outside and see what we were working with in the middle. So in the end, I would probably write this as 2 times x plus 2 times x minus 6. Okay, and you know the order doesn't matter for these, right? You know that this could be 2 times x minus 6 times x plus 2, and it would be the same thing. Okay. All right, 3x squared plus 15x minus 72. As soon as my first coefficient is not 1, I'm going to think about whether there's a greatest common factor. And there is. Each one of these is divisible by 3. So let's pull out our 3. And that leaves me with x squared plus 5x minus 24. So now a times c is -24 and b is 5. So what do I multiply together to get -24? That's going to add together to give me 5. And so let's see, 2 times 12. No, the difference between 2 and 12 is 10. That's not what I want. 3 times 8. The difference between 3 and 8 is 5. So that is what I want. 3 and 8 are my numbers, but one has to be positive, right? And one has to be negative. If I want to add them together and have a positive 5, the bigger guy has to be the positive. So I'm going to have positive 8 and -3. Okay. Watch this. I know positive 8 and -3, I know those are the numbers that I'm going to break my center guy into. So I'm actually going to skip these steps. I'm going to skip these steps. Watch what I'm going to do. I'm going to keep my 3. I know that to get a trinomial like that, remember I was doing guess and check earlier? I know my first terms have to be x's, yeah? Look, I have plus 8 and -3. I know the other parts of my binomials just from that little x puzzle. So that's what I want you, it's a little shortcut, right? As soon as you know that, you can plug those in. This works if your leading coefficient is 1, and it was by the time we were breaking up this trinomial. Okay, if you want to check your work here, here's what you're going to do. First multiply your binomials. Okay, so if I'm checking to make sure I get back to the original trinomial, first I'm going to say 3 times. Now I'm going to do FOIL. X times x is x squared. Negative 3x plus 5x, excuse me, I did my answer. Negative 3x plus 8x is 5x, and then 8 times negative 3 is negative 24. Okay, so all I did so far was multiply those binomials together, and now I'm going to use distributive property to check and make sure I get back to the original trinomial. So 3 times x squared is 3x squared, 3 times 5 is 15, so I have 15x, and 3 times 4 is 12, carry the 1, 3, 6, 7, negative 72. Is that what I started with? Yes, hooray! So my check works. Okay, so the back side of your page is really class practice. Again, it's fine with me if you want to kind of do some guess and check. I know my leading coefficient here is 1, and so you can say, I know it's going to be x, and everything's positive, right? So you can think, what do I multiply together to get 8, but they add together to get 6? Well, my options for 8 are 1 times 8, and I add those and get 9. That's not it. Or 2 times 4, right? And 2 plus 4 is 6. So I know it's 2 and 4. Or you can fill in your X puzzle. Or if you want to think back to one of our earlier examples, we used this little factor sum box. So, which is really, it's really the X puzzle, but it's all broken out. So lots and lots of ways to do these problems. Try this practice work. Whoops, there you go, sorry. Try this practice work, put the video on pause and come back and check, and I will say good luck and thanks for watching. When you finish and check your work, you can skip through and just check your answers if you want. Okay, so for a lot of these, I'm going to do a little bit of guess and check and go straight here to, I know this is x plus 2 times x plus 4. With positives, I'm not quite so concerned about checking my work, but as soon as I have any negatives, I do want to be sure that I don't have the negative in the wrong place. Okay, I'm going to do this as guess and check also. I know that I have to have two negative numbers. Two negative numbers. It's going to be x minus something and x minus something. I know that because I have to multiply negative by negative to get a positive for my last term. Okay, so I need two things that multiply together to give me 16, but they add together to give me negative 10. And so, of course, 16, I thought, oh, 4 times 4. Well, that's not it. But 16 is also 8 times 2. So if I have negative 8 times negative 2, I can double check that, check it. Right, x times x is x squared, outer is negative 2x, inner is negative 8x, so that's negative 10x, and then last is positive 16. Okay, so that's how you can always check your work. So in both of these cases, I'm not using that x puzzle, but please do if that makes sense to you. I'm just old and that's not how I learned it, so it's not my go-to. All right, x squared minus 2x minus 63. If I use guess and check, which I am, I know that one of these is, they're both going to start with x, right? Because x times x is x squared. One is going to be positive and one is going to be negative, because that's the only way I can multiply to get to a negative number. And 9 times 7 is 63, and the difference between 9 and 7 is 2, so those are the numbers I want. I need to have a negative 2, though, so if I'm talking 9 times 7, the bigger one has to be negative, so I'm going to say minus 9 plus 7. If I check, which I should do when there's negatives particularly, x times x is x squared, outer is 9x, inner is 7x, and last is negative 63. X squared minus 2x minus 63. Really check, because here's where you're going to figure out if you accidentally had the positives and negatives mixed up. Okay, over here, yes indeed, I'm going to try to guess and check x, x. I know one has to be positive and one has to be negative, right? The bigger one has to be positive. So 18, let's see, 18 is, and here's where I tend to do the kind of box thing. So I know 18 is 1 times 18, but when I add those together, it's 19. That's not what I want, right? I need 7. So 2 times 9, oh, there's my 7. So 2 and 9, 2 times 9 is 18, and if I have a, let's see, I want a positive in this, if I have negative 2 and positive 9, I'm going to have 7 in the middle, right? Negative 2, positive 9. See why you have to check, because that was some circular logic, right? Let's check it. and make sure I got that all right. So my firsts are x squared, outer is negative 2x, inner is positive 9x, and last is negative 18. So I have x squared plus 7x minus 18. Check, that's what I wanted. Okay, x squared minus 15x plus 54. I know already that I need two negative numbers to get a positive product, right? And then I want to add them together and have a negative in the center. And I know it's 9 times 6, right? Okay, over here I have x, I'm going to have a plus and a minus because that's how I get a negative over here. And let's see, 6 times 5 is 30, but you add those together and you get 11. 10 times 3, that's what I want. 10 times 3 gives me 30. I want to have positive 7 in the middle. So I'm going to have my bigger number be positive. Okay, if I check, it's x squared minus 3x plus 10x is plus 7x minus 30. This is my check. And I got the right trinomial, so I'm happy. Okay. Looking at number 7, I see that my leading coefficient is not a 1, so immediately I'm going to check and see if there's a greatest common factor. 5 goes into all of that, so I have 5 times x squared minus 3x minus 5 goes into that 28 times. All right, so I'm about to have students walk in, so maybe I will quickly just give you the answers on these two. This is going to end up being 5 times x minus 7, times x plus 4. All right, remember to check it. You do your binomials and then multiply by 5. And then over here, I'm going to actually pull out a y. I'm allowed to do that. Y times x squared minus 6x plus 8. It's okay, we can pull out a variable, no worries. And then when I factor, I'm going to get y times x minus 2 times x minus 4. Okay, thanks so much for watching.